Hi friends, in this video we are going to see Unit 4 from Operating System subject. Unit 4 is about file systems. Let's start our discussion. We are discussing the operating system, Unit 4. Here the syllabus is like this: concept of a file, access methods, directory structure, file system mounting, file sharing, protection, mass storage, file system structures, disk structure, disk attachment, disk scheduling. Okay. What is a file? File is a named collection of some related information. Okay. This is the definition. Stored on some medium, right? Named collection of items. File is a named collection of items. That is the definition. So you need to remember the definition, right? So next, go to the accessing method. How many types of accessing method? There are three types. First one is sequential, right? Second one, direct access. Third one, index access. Sequential means first you can access one. Number two, you access after completion of number one. If you want to access number 10, if you want to access number 10, you need to go through the all the items until 9 so that you will reach the 10. That is the sequential. Suppose if it is the direct access, if you want to access number 5, so it goes directly to that particular number, that particular item in the storage. That is the direct access. What about the indexing? What about the indexing? You have seen many times of indexing, textbooks. They give some chapter and a page number, chapter and page number. That page number and chapter collection is a index. So if you want to see some particular topic in the textbook, you see the index and we go to the directly that page number to get our topic in the textbook. That is the indexing. First one sequential, second one direct, and third one indexing. That's all. Next topic is directory structure. What is a directory? Under a directory, you can create many files. You can create many files under the directory. Here, the directory, there are 4 types given here. So first one, single level directory. Second one, 2 level directory. Third one, 3. It is a tree structured directory. What is the fourth one? Acyclic graph directory. Acyclic graph directory, right? Single level directory. And in the single level, only one level is here. Here, cat. Under the cat, how many? What are the files? There is only one level. There is a directory and files. There are no subdirectories. Okay, under single level. 2 levels. It's on. There are subdirectories in the middle. See, this is the first level and second level. 2 levels are there. Next, tree structure. Here the files are organized just like a tree. There is some root and branches. And last, there are leaves. Root, branches, leaves, right? At leaves, we find the files. This is the tree structure. Fourth one, what is the fourth one? Acyclic graph directory allows files to have multiple links or pointer to different directories. This allows for shared files among the directory but prevents cycles from occurring. What it means, if there should be no cycles, there should be no cycles. That is called acyclic. Acyclic means no cycle is allowed. Acyclic means no cycle is allowed in the graph. This is graph. Okay. This is tree. This is two level. And this one single level. Right. This is about directory. Directories are four levels: single level, two level, and tree structure, and then fourth one, acyclic graph directory. You write the definition for each item and also diagram also required. File sharing and protection. You can study that one. File system structures. There are different types. Like first one here is file allocation table, old way of file systems, and then indexed allocation, Unix file system, and new technology file system. If they are asking, you mention these four types of file systems. This NTFS for Windows. This is for Linux. Next one, mass storage structure. Mass storage structure is for what? For storing the large amount of data, See here, how many letters are there? 1, 2, 3, like that. We combine all this and we form one disk. Usually we call them as hard disk. Hard disk contains, like you know, right? Hard disk 500 GB hard disk, 1 TB hard disk, 2 TB hard disk. These are the mass storage structures. Hard disk drive, HDD, we also call them. And now in recent days we are using the solid state drive. This is the structure. Here, this is the stand and readers, read-write headers. These are read-write headers. And in the middle, there is a spindle for rotating. The plotter is like this, and in the plotter, there are many circles. These circles are called as tracks. And each track is divided into sectors. This is, I am writing S, right? These are the sectors. We rotate this spindle for data read and write. Next, disk scheduling. For accessing and retrieval of disk storage, we need disk scheduling. Here, we have some requests given for data access in our disk. We keep those requests in some queue. First algorithm, we are looking at the first come, first serve. So first request is for data 98, 183, location 183, location 37, and then 122, 14, like that. This is the order of the request for data locations to read the data in a particular location. Header is there at 53. So it is starting at the number 53 and going to the next number. What is the next number? 98. Then what is the next number? 183. Okay. Go to the, see the order. First one, 53, and then 98, then 183. Come to the 37. Again, 122 and 14. Then 124 and 65, 67. This is the first come first serve. First come, which came first? 98. Which came last? Right. First one given in the first, and last, whoever comes in the last will be given chance at the last. Okay. These are the locations user want to read. If you follow this order, we calculate the time. How much time it is taking for completing all these requests. We calculate that time and we find the best algorithm. Second one is shortest seek time first. We already seen shortest seek, shortest job scheduling from in the CPU scheduling. Same like that. Whatever the shortest seek time, we go for that one. We select a request with the shortest seek time from the current head. Suppose you are at uh, suppose you are at 37. From 37, what is the nearest one? Suppose in the right side it is 14. 14 is the nearest one. We go to the 14. After 14, we go to the 65. Then 67. After 65, we go to the 67. Like that. After 67, we go to the 98. That is the order. Shortest, seek time. Whatever the nearest one, immediate nearest one, we go to that one. To save the time only. The idea is to save the time. Next one, scanning. Here, the header, the read-write header of this moves from one end to the other end. Moving from one end to other end. Like starting at the 53, as usual, we have seen in the first come, first serve. And then go to the left side initially. It is going to the left side, going to the left side. But all are the requests in that left side, it will read. And as it will start going to the right side. So whatever the request left side of 53 will be read first in the first. So 37, 14 completed. And there is no zero, but it is going to the zero. That is the disadvantage here. Unnecessarily going to the border, unnecessarily going to the ends. This is the waste of time. Okay. This is also called as elevator down. Next one, circular scanning. Circular scanning. In this circular scanning, what happens? You see, it is moving from 53 to right side. Moving from 53 to right side. And in the reverse direction, it is not reading any request. See, this straight line, it is not reading any of the data, any location from details. So again, it start reading from the left side only. Again, it is start reading from left side only. See here, it is a circular motion. Starting from here and going to this side, again coming to the this side. This is a circular motion. That's why it is called as circular scanning. Scanning means scanning from one end to other end. What all are the requests you encounter on the way? That will be read. Two other algorithms also there, but we don't need. you read at least till the C scan. So what is the first algorithm? First come, first serve, shortest seek down first, and scan algorithm, C scan. These four are enough. So this is all about the unit. This is all about the unit 4. So what is a file? What are the accessing methods? You read and directory structures. 4 types we have seen. Four types of directory structure, file systems, 4 types of file systems, and disk structure. You also remember this diagram. You practice. If any case you see any question in the exam, you can write that. And disk scheduling, 4 types of disk scheduling. Okay, we will meet the next video.